channel. So in this tutorial we shall be looking at this LeetCode question, which is part with maximum gold. So in a gold mine, grid of size n by n, each cell is in this mine as an integer representing the amount of gold in that cell. So 0 if it is empty. Return the maximum amount of gold you can collect under the conditions. Every time you are located in a cell, you will collect all the gold in that cell. From your position, you can walk one step to the left, right, up and down. You can visit the same cell more than once. You never visit a cell with a gold. With 0 gold, you can start and stop collect from any position in the grid that has some gold. Okay, so we have example here. This is a grid explanation. Part to maximum gold, you go from 9 to 8 to 7. That gives us maximum. Here you go from 1 to 2 to 3 to 4 to 5, 6 and 7. That gives us the maximum gold. So the grid length is m equals to m. The grid length for the row is n. So m could be 1, minimum of 1, and maximum 15. The values there could be 0 up to 100. At most 25 cells containing gold. So, well, this is an interesting question. How do we approach this question? Obviously, we see that it's showing us this is a graph question, and we have to traverse through the graph. There may be needs for us to backtrack. For instance, when we have things like that does not meet the requirement, you should not visit the same cell more than once. Okay, so we need a way of keeping track of the maximum for every traverses, and we return the maximum. All right, so I think we got some idea. And is there any base cases? So our grid, they've said that we should always cannot be empty. So we have 1 for the rows, and columns maximum is 15. Okay. So first, what we want to do is we want to get the number of rows, and that is going to be the length of the grid. And we want to also get the number of columns, and that's going to be the length of the first value in the grid. Okay, so we have that. Then we want to return our result. Initially we say it is 0 because that's the first we can have, and at the end of everything we're going to return the result. Okay, that gets it there. So we have some things in between here. Now, so what we need to do is that we need to traverse through. So let's say we start from here. We need to start from the first place, and we go through that, and we call it DFS for us to be able to get the maximum in each of those traverses. So for that we can say for row in range of our n rows, and then we can say for column in range of our n column. So I like to use this here to be consistent. So what we now need to do is we are going to need to call a DFS, which we have not implemented, with the current row and the current column. Okay, and whatever it returns, we're going to put it in result based on whatever is the greater between our current value of result and what is returned. Okay, that is as the maximum good. Okay, so we're getting there now. So we're sure that with this we can go through all the grids. So starting from here, we go through all the grids, and we're going to call a DFS that will do the transversal for each of those each of those index that we're in. So this is a general approach to most of these transversal questions, where you need to first of all something like this. Okay, so let's implement our DFS now, where the bulk of the work is. So our DFS is taking a row and it's taking a column now, and we need to implement that. So to implement our DFS, there are some cases we need to first of all know when to backtrack. So we divide it into two cases. So our base case and the recursive case. So the base case and the recursive case, that's what we normally have in recursion. So the base case is when we backtrack. That is when we have either, so if the row is less than 0, so we have to backtrack, or the column is the one that is less than 0, we have to backtrack, or the row is greater or equals to, and that is length of row, we have to backtrack. If not, we enter into index error, or the column is greater than or equal to length of column, we have to backtrack. Then another important thing we need to is we don't need to visit a cell that has a 0. So if all of the preceding one are satisfied, we have to be sure that the cell, which is the grid, the current grid we're in, so looking at the row and the column, we have to be sure it is, if it is equals to 0, then we also have to backtrack. In that case, we are going to return, what do we return? We're going to return a 0. Why are we returning a 0? Because we know that the good we can get from that is a 0. And another thing is because in our recursive case, we are going to be returning an integer. So here we can't just say return, because this one will be returning none and this one will be returning an integer. We're going to get into an issue there. Okay, so that's done. So once we are done with that, so that means on getting to this, we are sure that df, the grid row and column, has a value that is not 0. So we need to put that value into a temporary into a temporary variable, and the reason for that is I will show us why we're doing that. So put column here. So we put this, and we are going to now set this grid row column to 0. The reason is we don't want to come back and encounter this current row and column again, because we are going to do a recursive call. So we need to get rid of this current row and column. That's why we are setting it to 0. That okay, we don't want to visit this same cell again in every single iteration, that is in every single traverses. So now we are traversing this unique row and column, so we want to set this to 0 so that we will not continue to traverse this value, if that makes sense. And once we are done with our traversals, we're going to call DFS here, we will return the value back to it. So grid, row and column will return the value back to the temp. once we are done. Okay, so here is where we're going to do our recursion. So in our recursion, so what we'll be doing now is, so we are already, we come here like 0, so we will not enter here. Then we get here, this is 6, so we'll put 6 into our term. Now we're going to now go to the left, right, and top and bottom of 6. So to be able to do that, we will now need to call DFS on the row plus 1 of column. Then DFS will be called, that's 4 times the row minus 1 of column. Then DFS again, the row column minus 1. Then DFS the row column plus 1. So that's like going up, down, left, and right. Now each of these is going to return, this is unique, all this transversal is unique for this particular row column. So each of this is going to give us some values, whether 0, whether 4, whether 5, whatever value it gives us. What we actually need in this is the maximum of all this thread. Let's call it like we send forth 4 workers to go and do some job. Each one of them is reporting back to us with a result, but we want the maximum of them. Okay, so how do we get the maximum? So we need to get the maximum from all of this. So we can say max of all of this one. So we want the max of all this. So I will just put it back appropriately. So the reason why I did it that time is to show us clearly, and so put us this back. So this gives us the max. Now what are we going to do with the max? We are gathering gold, so we are collecting gold. So we already have this temp and we are gathering gold. So the gold that we gather here, we will need it to add it to this already temp, and that's what we're going to return for this unique row and column. So but we cannot put a return here. If we put a return here, we will not be able to set this back. We can't do anything after our return. So because we need to set this back, we first of all need to put this in another kind of temporary variable. So can I call it temp2? So whatever result it gives us, we put it in a temporary variable, and we can now do a return after we set it back. So we set this one back. So what we'll be returning is the initial value of that particular row and column. Then the workers, what did they return? They return 4 value, the maximum of that worker. So that's what we're going to be returned. That's temp2. I hope that makes sense. So that is, I think that's pretty what we need. So the major place where we have bulk of the work is here. That's where we have the bulk of the work. And the base case is very clear, so it's standard. These are standard base case to check for the indices. The only other thing is this one, we don't need to go through this. If it's already 0, we know that the result is 0, so there's no need. Another thing that is trickish there is we need to get the current value temp, because we know we are accumulating it and returning a plus whatever its workers, which this thread, each one of them goes through. And to do that tweak is we store it in a value here so that we can be able to add it for our return. Okay, so it's difficult to actually do a walkthrough of this to dry run it, so I'll just believe that everything is okay and we can just run it. Normally we're supposed to dry run it here, but to dry run a recursive function is very hard to keep track, and take time. So let's see what it gives us. So let's run. Hopefully it runs. Oh, good. So that runs. So let's try the second case too. And let's see what it gives us. Hopefully that one too works. Yeah, that works. So, and let's submit and see whether it works for everything. Yeah, it's taking time. Oh, so something went wrong there. There's a time limit somewhere. 1111111. So let's see if we can quickly fix that. 11111. Is there anything we missed there? So that's a special case. So the only problem is difficult to dry run this. Say the time limit is exceeded on that. Mm. Mm. And don't seem to see any reason why it should not work. I don't seem to see any reason why it should not work. Yeah, that is 0. Base case. I'm recording our DFS, current row and column. Can I use I and J here and see maybe there's actually something going on? I don't think that's it, but let's just try and see. What is this particular one? Because I don't see any error anywhere. Let's see. Let's see. 1111111. A special case. Or could it be the 0? Maybe it's this one. That is, and that works here. I think maybe there's a problem with using this row and column here, because that's running here. So let's submit again. ING. I don't know why, because we're duplicating that. Something is wrong. Something is actually wrong with them, because it's running here. It's running here, so I don't know why it's not saying time limit and that. Okay, all right, that is it. Let's see the one we did before that got accepted. If there's anything different in it, I don't see anything different. Okay, the one that got accepted. Oh, okay, I think maybe this is the only way we're having that issue. If it's already, this can cut some time. If it's already if it's not 0, so there's no need for us to even do that. Maybe that's the reason why. So on the back end, they're doing some optimization, so I think that's why. So maybe we had this, so I don't think it's because I'm using the row and column, although it's always good to disambiguate that, but I don't think that's why. So it's just some optimization here that we don't need. If the grid of that current row and column, if it's equals to 0, we don't need to go there. So we only go if it's not equal to 0. So that's just an optimization. We only make a recursive call. We only have a case if it is not equal to. If it's 0, we can just skip that because we can't get out of it. I think this is the optimization. So let's see that again. Yeah. What's going on? Okay. So that works. So let's submit and see what gives us. Yeah. So this is the optimization that we need. We don't need to go into this recursive call. Okay. All right. Thank you very much, and see you in the next one.